Okay, this video is going over the notes for distance versus displacement. It's very similar to the note sheet, but I did want to go through a couple of these concepts. Okay, so first, what is the difference between distance and displacement? Distance is the total amount of ground covered by a moving object. It is a scalar quantity, so direction plays no role in distance, whereas displacement is how far away from its starting point an object ends up. So in this example, if this person went for a walk, then the distance would be the entire length of the loop that they did. But in the end, their final displacement is just the straight line between their start point and their end point. When an object goes in a variety of directions, your displacement is always going to end up being smaller than the total distance. And as you can see in this image, the total distance is pretty long compared to the size of the displacement. And the reason this is because with displacement, because it is a vector quantity, the direction that the object travels does matter and does play a role in where it ends up in relation to its starting point. To calculate distance is really easy. All you do is add together all of the distances covered, add them together, and that is your total distance. What's important is that distance cannot be a negative number. It will always be a positive, whether the person is walking backwards or forwards, it does not matter, because you're just counting how far they moved total. So in this example, if Julie walks 6 meters to the east and then turns and walks 4 meters west, what is her total distance? We would take the 6 meters to the east plus the 4 meters to the west, making the distance a total of 10 meters. With displacement, it's a little bit different. We have an equation that we can use, which is x equals xf minus xi, where x is your overall displacement, xi is the initial position, and xf is the final position. Since displacement is a vector unit, the direction does matter, and so you can get negative values if the object is located in a negative direction compared to where it started. Which then brings the question, what is positive versus negative direction? Think of it in terms of a coordinate plane, like in math. If you're going upwards or north, east, or to the right, it's going to be considered positive direction. And that's where on your number lines, on your x and y axes, that's where you have your positive numbers. So it's a positive direction. Whereas if you're going south or downward or to the left or west, then it is considered a negative direction. And again, looking at the coordinate plane, that's where you have your negative numbers. So moving to the right will be positive, and then if you turn and move to the left, you'll be moving in a negative direction because you're moving towards those negative values. So going back to the problem from earlier, Julie walks 6 meters east, then turns and walks 4 meters west. Figuring out her total displacement, we can use our x equals xf minus xi equation here. Xf, her starting point is 0. She walks 6 meters east, so she would be at 6 on the number line, and then 4 meters west, which would bring her to an ending point of 2 on the number line. So we can write out our variables. This is our equation. We have 3 variables, x, xf, xi. X is what we're trying to solve for. Xi, her initial position, is 0. Xf, her final position, is 2. And when we substitute that into the equation, we have x equals 2 minus 0. So her final x is 2. So she is 2 meters from her original position. Since it's a positive number, we know that the final position of Julie is to the right of where she started. It's in the positive direction. Let's look at another example where it might get a little bit different. In this case, Kent walks 2 kilometers east, 8 kilometers west, and then 4 kilometers east. What was his total distance traveled and what was his final displacement? So I'm going to have him start at 0, walks 2 kilometers east, then 8 kilometers west, so 2, 4, 6, 8, and then finally 4 kilometers east, 2, 4. So he ends at a -2. So my distance, again, doesn't matter what direction I traveled. It's just all that matters is that you traveled that distance. So I'm going to add all of those distances together. 2 plus 8 plus 4 gives me a total distance of 14 kilometers. For my displacement, I'm going to use my x equals xf minus xi equation. Again, I have 3 variables. So x is what I'm trying to solve for. My xi is 0, and my xf, because I drew it on the number line, I know my xf is -2. So when I substitute those in, I have x equals -2 kilometers minus 0 kilometers. So x is -2 kilometers or 2 kilometers west. Both answers are correct. You can either distinguish the direction by using the actual direction. So in this case, we're talking east and west. So I could say 2 kilometers to the west. Or instead of saying west, because west is considered a negative direction, I could just give my answer as -2 kilometers. When we get into later calculations, understanding that a negative direction means we want to make sure we put in a negative number is going to be really important. Okay, so comparing distances versus displacement values. Sometimes distance and displacement are going to be identical. They will be the exact same number. That is the case when the object only travels in one direction. So for example, A travels from 0 to looks like about 7 here on our number line. So the distance would be 7 meters and the displacement would also be 7 meters because the object only moved in one direction. B went from 12 to, again, about 7. So that would mean that the distance is 5. The magnitude, or the numeric part of my displacement, is also going to be 5. But because it's going in the opposite direction, because it's going towards the negative, my displacement would be -5, but my distance would be +5. And again, that's because distance cannot be negative, and displacement, I want the person looking at my numbers to know that I mean to the left, so I put -5. Looking at C and D, where there's changes in direction, our distances and our displacement are never going to be equal. Anytime that there is a change in direction, if you start in the negative and move to the positive, or start in the positive and move negative, then your displacement and your distance will end up being different, and your displacement will always end up being smaller than the total distance traveled. Because if we look at C here, it's going from 2 is my starting point, 10 is my ending point, so that's a displacement of 8 meters. But if I calculated the whole distance, I have from 2 to 10, which is 8, 10 to 8, which is another 2, and then back to 10, which is another 2. So in this case, the object traveled a total of 14 meters, but my displacement, again, is simply 8 meters. All right, what do we do if we don't have a number line, or if we have numbers that don't make sense to use, like to draw our own number line to create? We can still calculate our displacement easily without using a number line. In this situation, I'm given actual distances that an object has moved. Now I could draw it on the number line like I did before with the example of Kent and Julie having my runner start at 0, draw out to 202 meters, and then draw back and figure out what those values are going to be and use my equation. Or I can simply pay attention to the direction and use that to find my displacement. So in this example, if I was finding my distance, it's still 100% the same as everything that we've done previous. I take all of my values, the 202, the 176, the 94, and the 312, and add them all together, and I get a total distance of 784. For my displacement, I have to pay attention to direction. The jogger runs 202 meters west. That's going to make it a negative value. So I would put negative 202. Then 176 east, which means 176 is going to be a positive. So I have negative 202 plus 176. Then goes another 94 east, so plus another positive 94. And then finally 312 west, which means I'm going to add negative 312. And it's negative because it's moving westerly. So I would have negative 202 plus 176 plus 94 plus negative 312. Meaning my runner, when they stop, she stops 244 meters west of her starting position. And again, I can give that answer as either 244 west, or I could simply write negative 244.